Hello and welcome. We are discussing PYQs of equations and arithmetical reasoning. Our theme is script arithmetics and we have solved few problems already. Let's check out this next one. This problem says a three-digit number ABC, which, which means the minimum value of A can be 0 and the maximum value of A can be 9. Similarly, the minimum value of B can be 0 and the maximum value can be 9. Same goes for C. Is multiplied with D. So ABC is multiplied with D. Let me write it down over here. ABC multiplied with D and the result obtained is 37DD, where 37DD is a 4-digit number. 3 is thousandth digit, 7 is hundredth digit, D is tens digit, and the next D is units digit. Where A, B, C, D are different non-zero digits, meaningly the minimum value of each of these alphabet can be 1 and the maximum value of each of these four alphabets can be 9. It cannot be more than 9 because these are what? These are digits. Okay, let's solve this further. Now, keeping this A, B, C as it is into D as it is, and let's expand this 37DD. If I expand it, it's gonna give us 3 into 1000 plus 7 into 100 plus D into 10 and the final D as it is. Okay, solving it further, so A, B, C into D will be equal to 3700 plus 11D. So A, B, C will be equal to 3700 plus 11D upon D. Please make a note of it because I need a lot of space for writing down a lot of information related to this particular question. Okay, so please note down at the same time. Now, if I solve this further, I will be getting what? A, B, C is equals to 3700 upon D plus 11D upon D gonna give me 11 only. So this is my equation number 1. This is what equation number 1. Please make a note of it. Hurry up, hurry up. Don't waste time. Please make a note of it. Huh? Now, what I can say? See, ABC is a 3-digit number. So it is what? It is an integer also. So if my left hand side is integer, my right hand side has to be integer. If I want my right hand side to be integer, it is only possible when D will take a value which will divide 3700 completely, because 11 is integer itself. So I need to consider such a value of D which will divide 3700 completely. Now I know D is a non-zero digit. So minimum value of D can be 1 and the maximum value of D can be 9. At the same time, D should divide 3700 completely. So first value that D can take is 1. 3700 is completely divisible by 1. So if I assume D to be equal to 1, this equation will become ABC equal to 3700 plus 11, which is 3711. Now this is not justifying my one more condition which is given in the question, and that condition was ABC is a 3-digit number, whereas 3711 is a 4-digit number. Although D is dividing 3700 completely, but still this assumption is missing one of my condition which is given in the question. Hence, D cannot be equal to 1. Now, another value that will divide 3700 completely is 2. So, if you put D to be equal to 2, so this equation will become ABC is equals to 3700 upon 2 plus 11. What is half of 36? Half of 36 is 18. So, so it becomes 1850 plus 11, which is equals to 1861, which is equals to what? 1861. Now again, 1861 is a 4-digit number, which is the value of ABC. Now according to this, value of ABC is 1861. 1861 is 4-digit number. I want ABC to be a 3-digit number, so D cannot be equal to 2 as well. Now next value that will divide D completely, this 3700 completely, will be 3. No, it not be 3 because 3700 is not completely divisible by 3. So next value that will do it is 4. Now if D is 4, so this equation will become ABC plus 3700 upon 4 plus 11. Let's solve this. 4 nines are 36. 4 nines are 36, 4 twos are 8, 4 fives are 20. So 925 plus 11 is what? 936. Okay, so ABC is a 3-digit number, 936 is also a 3-digit number, hence my all conditions are justified, which means A is equals to 9, B is equals to 3 and C is equals to what? 6. I want what? Sum of A plus B plus 6, which means 9 plus 3 plus 6 is what I'm looking for, and this answer 18 is present in the option also, hence option A is the right choice. Please make a note of it. Please make a note of it. Hurry up, guys. I hope this is clear. Now, apart from it, no other values of D will justify all my given conditions. Hence, we can discard them. Let's move on to the next question. It says, let P, P, Q, Q, R, R be 2-digit number where P is less than Q is less than R. If P, P, a 2-digit number, Q, Q, another 2-digit number, and R, R, then another 2-digit number. If you add 3 2-digit number, then the maximum value of the 100th digit of the result will be 2 only. If you add 3 2-digit number, then maximum value of the 100th digit of the result will be 2 only, and minimum value can be 1 only. Now you can ask me, sir, why not 0? If you consider T to be equal to 0, so result is what? 0, 0, 0. How come that you are adding 3 2-digit number and your result is 0? Alright. So the minimum value of T can be 1 and the maximum value of T can be what? 2. So if T is equals to 1, so this equation will become, now see, PP is a 2-digit number, can be written as P into 10 plus P. QQ is also a 2-digit number, so it can be written as Q into 10 plus Q. And RR is also a 2-digit number, so RR can be written as R into 10 plus R, which is equals to, if T is equals to 1, so TT0 will become 110. TT0 will become what? 110. Now, if you solve this further, it is what? It is 11P plus 11Q plus 11R equal to 110. Solving it further, 11 can be taken common, so P plus Q plus R is what? 110. 11 and this 110 gone, so P plus Q plus R should be equal to 10. Okay, if P plus Q plus R is equals to 10 and P should be less than Q should be less than R, it is also given. Then let's talk about what are the possible value that P can take. Sum of three single digit number should be 10. Let's check out all the possible value of P. So P plus Q plus R is equals to 10. So the minimum value of P can be like, some of you may say, sir, minimum value of P can be 0. If minimum value of P is 0, then PP, which means 0, 0, won't be a 2-digit number. If I'm saying that PP is a 2-digit number, then definitely there has to be some value more than 0 attached to 10th digit of PP. So the minimum value of P cannot be 0, it should be 1. If P is 1 and Q should be greater than P, so Q has to be 2 and R can be 7. So 1 plus 2 plus 7 is what? 10. Now 1 plus 3 plus 6 is also 10. So we are considering what are the different values that P can take. So till now P is 1, P is 1. So 1 plus 4 plus 5 is also 10. 1 plus 6 plus, sorry, 1 plus 5 plus 4. This is not considerable. This is not considerable. Why? Because P should be less than Q, should be less than R. 1 is less than 2, less than 7. 1 is less than 3, less than 6. 1 is less than 4, less than 5. But 1 is less than 5, but 4 is not less than 4 is not greater than 5. So this is discarded. So till now I can see the only value that P can take is 1. What are the other values? What if P is equals to 2? So 2 plus 3, because Q has to be more than 2. Q has to be more than 2. So 2 plus 3 plus 5, 10. 2 plus 4 plus 4 cannot be considered. Why? Because R should be more than Q. So this is discarded. So I can see from this equation, from this condition, maximum value that P can take is 1 and 2. Maximum value that P can take is 1 and 2. Q can take 2 as a value, Q can take 3 as a value, and Q can take 4 as a value. All right. Now, this is the first condition. Please make a note of it. Hurry up, guys. This is the first condition. Please make a note of it. I hope you have noted it down. Now, what if T was equals to 2? What if T was equals to 2? If T was equals to 2, so 11P plus 11Q plus 11R will be equal to 220. Will be equal to what? 220. If I add them, it becomes 11 into P plus Q plus R is equals to 220. If I solve this further, P plus Q plus R is what? 20. Now, I got one more condition. P plus Q plus R can be 20. At the same time, P should be less than Q, should be less than R. Now, let's check it out. Check it out. Now, I want P plus Q plus R to be 20. Okay. I know P can take 1 as a value, P can take 2 as a value. So let's think about what other values P can take. So let's go for 3. If P is 3, Q can be 4. 3 plus 4 is what? 3 plus 4 is 7. 7 plus 13 is 20. But this is not valid. Why? Because R is a single digit number. R is what? R is a single digit number. R is what? It's a single digit number. All right. So R cannot take 13 as a value. Okay. Now, so if P is 3, let's consider Q to be 5. Let's consider Q to be 5. So 3 plus 5 is 8. 8 plus 12 is 20. This is not also valid because R should be a single digit number. Not valid. Now, 3 plus 6 plus 3 plus 6 is 9 plus 11. Not possible. It is not possible. Okay. Now, let's check out the other values. Let's check out the other values. Now, just a second. Let me consider P to be 3, Q to be 8 and R to be 9. Will I be getting 20 here? Yes. At the same time, 8 is more than 3, 9 is more than 8, and the condition is justified, which means P can take 3 as a value as well, and Q can take 8 as a value as well. Q can take what? 8 as a value for sure. Now, what are the other conditions? So, all the possibilities with 3 are exhausted now. Now, let's assume P is 4. If P is 4 and maximum value that R can take is 9, P is 4, R is 9. So Q can take 7 as a value because 4 plus 7 is 11 plus 9 is 20. So one more value that P can consider is 4 and one more value that Q can consider is 7. Okay. Now, what are the other possibility? What if P is 5 and Q is 9? P is 5, Q is 9. 9 plus 5 is 14 plus 6 is what? 20 also. Again, the condition is got justified. P is less than Q is less than R. So next value that P can consider is 5 and the very next value that Q can consider is 6. Okay. Now, I see. Now let's check it out. Is it possible that Q can take 6 as a value? So if Q is 6, then maximum value that R can take is 9 because R is a single digit number. So 6 plus 9 is what? 15. So Q must be equal to 5 to make it to be equal to 20. Now this is not valid. Why? Because Q should be greater than P. 5 is not greater than 6. Hence this can be discarded. So no other case gonna be possible now. So I can see how many value P can take. P can take 5 value. Hence statement 1 is correct. And how many values Q can take? Q can take 6 values. Hence condition, the statement 2 is also correct. So option, the right choice of this question is option C. Please make a note of it. Hurry up guys. Please make a note of it. So this is all from my side for this video. Thank you so much.